This video will cover 11C notes, which is adding and subtracting rational expressions with like denominators. Adding rational expressions, remember rational is like a fraction, but we have polynomials instead of just numbers. So when we were adding numbers back in middle school, we would have something like 3 over 20 plus 7 over 20. Now remember, you cannot add or subtract fractions unless they have a common denominator. If they do, like 3 over 20 plus 7 over 20, then all you have to do is add the numerators together, so 3 plus 7. But remember, the denominator stays the same, the 20. Then, if the fraction can reduce, we reduce it. So this reduces to 1/2. Okay, so now we're going to do very much the same thing with a rational expression. Remember, a rational expression is a polynomial divided by a polynomial. We were, in the last two videos, simplifying polynomials, and then multiplying and dividing rationals, and now we're adding and subtracting rationals. Okay, so to add fractions or rationals with like denominators, and key here is we're like denominators. So we're just going to simply add the numerators together and keep the same denominator, just like we did in the example above. If there are like terms in the numerator, combine them. Then after the addition is complete, just like in our previous example, I had to reduce 10 over 20 to become 1/2, then you have the possibility of simplifying. So after the addition's complete, step 3 and 4 is basically to simplify, just like we did in the first lesson in this chapter. Okay? So for part A, first of all, you want to make sure that all of these have like denominators. In the next video, we'll look at examples when we do not have like denominators. So in part A, our denominator is the same, 4x plus 12. So all we have to do is add the numerators together. So that would be just x plus 3 over the denominator stays the same. Now, you cannot stop there because you have to see if this fraction can reduce. And to do that with rational, that means you factor. X plus 3 does not factor, so that's going to stay the same. Then 4x plus 12, the 4 can factor out, and 12 divided by 4 is 3. And now we have an x plus 3 in the numerator and an x plus 3 in the denominator, so they can cancel. Now notice I have nothing in the numerator. When that happens, you have to put a 1 in the numerator, okay? And then the 4 was left in the denominator, so that is our final answer. Okay? So we're just going to be looking at a lot of examples like that. Some might look a little bit different than others, so that's why we have a lot of examples. All right, so in part B, notice that I have a plus 1 plus a plus 5. And notice the denominators are the same in part B, a squared minus 9. So what you're going to do is you're just going to add all the like terms. So we have a and a, which are alike, so we're going to now have 2a. Then we have 1 plus 5, and that will become 6. Then the denominator stays the same. Okay, now we reduce. In the numerator, we can factor out a 2. In the denominator, notice that's a difference of squares, so that will become a minus 3 times a plus 3. A plus 3 cancels, leaving you with 2 over a minus 3. All right, example C. We have the same denominator, p minus 6. So now we just simply combine like terms. But now notice that I do have some subtraction going on, so you need to keep that in mind. So when you add the like terms, we have 2p plus 1p is 3p. And then negative 15 plus a negative 3. Those are both negatives, so when we add two negatives, we're only becoming more negative, and 15 and 3 become 18. Then, in the denominator, the p minus 6 stays the same. Now we factor. 3 comes out in the numerator, so we have 3 times p minus 6. And p minus 6 in the denominator does not factor. And so now the p minus 6's can cancel, leaving us with a 3 in the numerator. Now, in part A, we had both factors cancel out, leaving a 1 in the numerator. You have to write the 1 if that's what's left in the numerator. However, in part C, our denominator was completely canceled out. So this is like it would be 3 over 1, but if the 1 is in the denominator, we do not have to write the 1 because 3 over 1 is just 3. Okay? All right, and so for example D, again, we have the same denominator, 5c minus 10, so all we have to do is combine like terms in the numerator. 6, that does not have a like term, so it's going to stay 6. Then we have negative 5c plus 2c, which would become negative 3c. Then the denominator stays the same. Now factor. 6 minus 3c, their common factor is 3. When I factor out a 3, we get 2 minus c. In the denominator, 5 is the common factor, and when you factor that out, you get c minus 2. Now notice this is a little different because we have 2 minus c and c minus 2. Remember that those can cancel out, but they're opposite, so when they cancel out, we need to make sure we multiply by a negative 1. Now we have the fraction 3 over 5 left over, but we can just put a negative in front, and that is our answer. Okay, so the first example was adding fractions with like denominators. Now we're going to subtract fractions with like denominators. It's really the same thing. So at the beginning, we have 5 over 14 minus 3 over 14. So as long as we have a common denominator, when we subtract, we simply subtract the numerator. So 5 minus 3 is 2 over 14, and then we reduce. Okay, so it's very much the same thing. However, when I just had 5 minus 3, that was easy. 5 minus 3 is 2. But when I start subtracting polynomials, that's more than just one thing. So what's really important are these first two steps. Is I would want you to put parentheses around the numerator being subtracted. Really, that's the second numerator. Okay, so looking at example A, you see you have this first fraction minus the second fraction. Okay, so what I would do is I would put parentheses around the numerator of the second fraction. Then you're going to distribute the negative inside those parentheses. So this negative right here is going to distribute to each of those terms. Now it only distributes to the numerator. You do not want to distribute it to the denominator. Okay, so now we have the denominators are the same, so that's going to stay the same. I'm going to rewrite this one. Whenever I subtract, I don't like to just go ahead and combine like terms. I like to rewrite it first so that I do not make any mistakes. Okay, so we have 3x minus 4, that stays the same. Now I'm going to distribute the negative. So I have a minus x, and then a negative times a negative 2 will become a positive 2. Now I can go ahead and say all of that will be over that common denominator, 7x minus 7. Okay, now before I can start factoring, I have to combine like terms, because I haven't done that step yet. All I did was change the second numerator. I changed the signs. So now I'm going to combine like terms. So I have a 3x minus x. That becomes 2x. And then I have a negative 4 plus 2, which will become minus 2 over 7x minus 7. Now, once you've combined like terms, you will factor. So to factor out a 2 in the numerator and factor out a 7 in the denominator. So then the x minus 1's cancel, leaving you with the fraction 2 sevenths. Okay, so that's how subtraction works. So not only do you need to make sure that the denominators are the same, but now you need to look and see, am I adding or subtracting? Okay, so in part B, again, we are subtracting. Our denominators are the same. So since we're subtracting, I'm going to put parentheses around the numerator of the second fraction and then show that I'm going to distribute the negative. So m squared plus 5 stays the same. Then minus 3m. Then minus a positive 5 would be minus 5. The denominator is just going to be the same, m squared minus m. Now, in the numerator, this is the first example we have like this, in that we have the m squared. So we're looking for like terms. There's only one m squared in the numerator, so it's going to stay m squared. Now, remember when we have an m squared, we want to put this in standard form. So the next thing we want to put is the m term. So that's what I'm going to put next, is negative 3m. Notice there are no other m's in the numerator. Now we have the positive 5 and the negative 5. And when I combine those, positive 5 and negative 5 are just going to cancel to be 0. Okay? So that's our numerator. Our denominator has stayed the same. And now we're going to factor. So in the numerator, we have an m in common. So we factor that out to be m minus 3. In the denominator, we also have m in common, but that's going to be m minus 1. Now the m's are going to cancel, leaving us with m minus 3 over m minus 1. Okay, example C. Like denominators, and we're subtracting. So put parentheses and distribute the negative. So now we have 5c minus 12 minus 2c and then minus 9 over the common denominator 3c plus 12. Now combine like terms. 5c minus 2c is 3c, and then negative 12 and a negative 9, when you add those together, become negative 21 over 3c plus 12. Factor, and we have 3 times c minus 7 divided by 3 times c plus 4. The 3's then cancel, leaving us with c minus 7 over c plus 4. Okay, last example for subtracting, part D. Again, common denominator, yes, and we are subtracting. So we want to distribute. So now we have a plus 13 minus 5a minus 1 over our common denominator. Now, combine like terms, we have 1a minus 5a. 1 minus 5 is negative 4a. And then we have positive 13 minus 1, which is just positive 12. Denominator stays the same. Now we factor. Now notice when we factor, if our leading term is negative, we want to factor out a negative. So I'm going to do that here. I'm going to factor out a negative 4. So when I do that, I'm left with a, but when I factor out a negative from this positive, that will switch to a negative. So 12 divided by negative 4 will be negative 3. Then in the denominator, notice we have a quadratic. This is 3 terms, so we need to factor by a C method. So remember, the 6 can be a little tricky, so let's go work through this one together. So a times c is negative 6. I want to find factors of 6 that when I subtract them, because it's negative, when I subtract them make negative 1. Okay, so I need to have one of them being negative, and when I subtract, make negative 1. The answer would be 2 minus 3. Okay, so 2 times negative 3 is negative 6, and 2 minus 3 is negative 1. Always be very careful with 6 and double check before you end. Now, since this is a is 1, we can use the shortcut method by just saying that's going to be a plus 2 and a minus 3. Okay? Now we have the a minus 3's in common, so they can cancel, leaving us with negative 4 over a plus 2. Okay? Okay, so now we've added rational expressions with like denominators and subtracted. But now we're going to add and subtract with opposite denominators, okay? So that means if I have an x minus 2 and then a 2 minus x, how do you do it with that? So consider 7 over 6 plus 5 over negative 6. Those are opposite, same value but opposite signs in the denominator. So what you can actually do is you can make this 7 over 6, and so 5 over negative 6 is really negative 5/6. So if I'm adding negative 5/6, that's really subtracting 5/6. Okay, so notice that I took that negative from the denominator, and then I made that the addition become subtraction. So now I have 7 minus 5 is 2/6, which when it reduces is 1/3. So make sure you understand, look at these 3 things. We have 2 over negative 3, or negative 2 over 3, or the negative written in front of the fraction 2 over 3. These are actually all the same thing, okay? So make sure you understand that those are all the same. You do not have a negative both in the numerator and the denominator. All right, So when we add or subtract fractions with opposite denominators, you want to first change the denominator for the second fraction to match the first denominator. Then you're going to change the operation. So just like I did up at the top, 7/6 and 5/6, I made that second 6 positive to match the first one. And then I changed the operation from addition to subtraction. So when you change the denominator, you will change addition to subtraction, or if you were subtracting, you would change to addition. Then you just do the same that we did in the first two examples. So example 3. Notice that we have 2 minus x and then 6 minus 2x. Those are not the same, they're just simply opposites. So what I want you to do, if you see that these are opposites, then keep the numerators the same. And actually the first fraction is going to stay exactly the same. And so what you're going to do on the second fraction, you're going to just flip it to make it look like the first one. But remember, when you do that, you changed the sign. Okay, so instead of adding, we're now subtracting these two fractions. Okay, so now we just do like what we did in the first or second example. Now just simply subtract x minus 3 over 2x minus 6. Then factor to reduce, and we're left with 1/2. Okay, so that's all you have to look for, is see if they're opposites. You got to make sure and look at your examples to see if they are opposites. So in part B, we have opposites. So we have the first fraction's going to stay exactly the same. And then the second fraction, we're going to change the denominator. And when we do that, we change the sign to subtraction instead of addition. Now notice for this one, I'm subtracting the polynomials. So I want to put my second fraction numerator in parentheses so I can distribute that negative. So now I'm left with y squared plus 7 minus 6y and then minus 7 over y squared minus 2y. Then I combine like terms, so we have y squared. Now notice again we have this quadratic, so the negative 6y would come next, and actually the 7's cross out. I know that's the second example that we've had like that. That normally does not happen so much, okay? Then divided by y squared minus 2y. Factor out a y in both the numerator and the denominator, and now we're left with y minus 6 over y minus 2. Okay, we're going to do 2 more examples and then we're done. Part C. We have, again, opposite denominators, so we're going to leave the first one the same. Flip the sign from subtraction to addition, and flip the denominator. Okay, so now we add, so this one's a little bit easier because we don't have to distribute the negative. Add a plus b in the numerator. A squared minus b is in the denominator. And now a squared minus b squared is a difference of squares, which factors into a minus b times a plus b. So then the a plus b's cancel, leaving a 1 in the numerator and a minus b in the denominator. Okay, last example. So in part D, again, notice that our denominators are opposites. So the first one stays the same. The operation, the minus sign, changes to a plus sign. The second denominator flips because of the change in sign. Okay, and now we add like terms. Now notice when you're adding like terms here in the numerator, we're looking for, so the like terms, we have r, and then we have a minus r. Whenever you're adding like terms and you have a positive and a negative, those are actually going to cancel out. Okay, and then you have 5 plus 5. Those do not cancel out. That's going to become 10 over, the denominator stays the same. Now notice if I were to factor the denominator, and notice I'm not writing this down, I'm just, for real, I'm just kind of showing you if I were to factor out the denominator, you would get r times r minus 5. Notice that does not factor out or cancel out with 10. So this, what I have written, is my actual final answer. Okay? And that is adding and subtracting rational with like terms.